All right, so as I mentioned, today we'll look at 7.3 and 7.5, perimeter and area and volume. And so 7.4, we'll come back next class and knock that out. All right, oh, didn't get my erase. So we're looking at a rectangle, just going to generally look at a rectangle. First thing we'll look at is the perimeter. So for the perimeter, you do not need a formula. All you have to do is add up all your sides. Now there are formulas for certain shapes. You know, here's the perimeter of a rectangle. P equal to 2L plus 2W. And of course, this is our shape, the shape of our rectangle. So that is the formula for the perimeter of the rectangle, to calculate the perimeter of the rectangle. But once again, if you do not have a formula for the perimeter, that's fine. All you have to do is add up all the sides. And so when you talk about perimeter, the perimeter is the outside, like your fencing. But when you talk about the area is the inside, how much space a shape takes up. And so you will need a formula to calculate the area. So it's how much space or area, how much space a shape takes up two-dimensionally. And you will need that formula. So the formula here for the area of a rectangle is length times width. Each shape has its own formula. So triangle will have its own formula, circle will have its own formula, and so on. All right. And of course, if I were to scroll up,
Search at your own for me.
not do it too fast, let me know. All right. We're going to come back to the green boxes in a second. Now, the volume, you need a formula for volume as well, and that's how much space a shape takes up three-dimensionally. So the volume formula for a rectangle is length times width times height. So now you're including the height as a part of your calculation. And once again, it's the amount of space that a shape takes up two-dimensionally. All right. Questions so far? So now when you do your calculation to find the perimeter, area, and volume, you're going to always know which one you've calculated by the type of measurement that you have left. So in other words, and what I mean by that is that when I look at the volume, I'm always going to be in cubic measurement. After I calculate the area, my measurement would be squared. And then when I calculate my perimeter, it's going to be the regular measurement. So if I'm in inches, it will stay in inches. If I calculate the perimeter, it would go to inches squared because I did inches times inches to calculate the area. And then it would be cubic inches in volume because that would be inches times inches times inches. All right. Questions? Any questions? Any questions at all? All right, scrolling up. All right, so here it says find the perimeter and the area. I'm just putting that rectangular work into motion. So it has our length to be 30 inches, width to be 20 inches. So if the perimeter, to calculate the perimeter is 2L plus 2W, all you would do is plug in 30 for L, 20 for W. 2 times 30 is 60, 2 times 20 is 40. Add them together, we have 100 inches. All right. And then to find the area, length times width, so that's 30 times 20. That'll be 600 inches. And don't forget, the mistake erased it. So that's gonna be inches squared. All right. Questions? Any questions? Scroll up. All right, so the next one, find the area. They give us this triangle. So don't forget, every shape has its own formula. So the formula for a rectangle you cannot use on a triangle and vice versa. So here we have our base is 12. And then the height of the triangle is 6. The formula for the triangle is 1/2 base times height. So I plug those values in accordingly. 1/2 times 12 times 6. Half of 12 is 6. 6 times 6 is 36 centimeters squared. All right. Any questions on that one? Next one we have trapezoid, in which we have the top side is 6 feet, bottom is 14 feet, and then the height of the trapezoid is 7 feet. And that's our formula right there for a trapezoid, 1/2 times h times a plus b. So now a plus b, normally the top is given to a, the bottom is given to b, but they're interchangeable. Whether you do 6 plus 14 or 14 plus 6 inside the parentheses, you still will get 20. Did someone say something?
Never mind, I see it.
Okay, cool. All right. So 6 plus 14 will give you 20. Now, if I was doing this by hand, I would go ahead and, because you can multiply, as long as it's all multiplication, you can multiply in any order. I would go ahead and do half of 20 to get 10. And then 7 times 10 is 70. If you have a calculator, if you just throw it in the calculator like this, you'll still get the same answer. But that was just me doing it by hand. And once again, our measurement is feet squared. All right. Question before we go to circles. All right, good. All right. So looking at circles, the diameter of a circle is going from taking a line going from one end of the circle to the other and going straight through the center. That's your diameter. And then your radius is always going to be half of your diameter. If you go from the center just to one side or one end of your circle, that will be your radius. So they may not necessarily tell you this diameter, but if they were to give you that line, and let's say put the number 5 there, then you should know the diameter is 5. Same thing with the radius. If they give you that diagram, put a number there for R, then they would expect for you to know that that's the radius. And for you to know the relationship that if you have the diameter, take half of that, that's the radius. Or if you have the radius, multiply that by 2, then that's your diameter. And so that's all I emphasize over here in the green box, is that if you have one, then you have the other as well. So if I have 30, if I take half of that, 15, if I have 30 for the diameter, excuse me, if I take half of that, then the radius is 15. Or if they give me the radius of 7, multiply that times 2, that means my diameter would be 14. All right. All right, circumference is going to be C equal to 2 pi r. Area is pi r squared. Your circumference is the perimeter for circles. They just don't call it the perimeter because the perimeter is adding up all of your sides. Circumference is the distance around the circle. So I should do. All right, and then also pi, the rounded version of pi, the approximation of pi normally is 3.14. All right, so this next one, or this first example says find the circumference and area, give the exact and approximation. All right, give you a chance to write. All right, so they give us this diagram right here. Gives the circle with the diagram, not diagram, but the diameter being 20 inches. So that means our radius is going to be 10 inches. All right, so let's find the circumference. Remember the formula is 2 pi r. So I'll plug in 10 for r. And let me erase some of this stuff. All right, so I'll plug in 10 for r. That's 2 times pi times 10. So just like I mentioned before, you can multiply this stuff in any order. So I'm going to take the 2 and multiply it times 10 in order to get the most simplified way of expressing the answer without changing pi. All right. All right, so 2 times 10 is 20. And when they ask, if you go back to it, notice they ask for the exact and the approximation. So this would be considered your exact answer. All right, so next we want to find the approximation. And so 3.4 is normally what you would put in for the approximation. I've noticed recently though that WebAssign wants you to put in pi. In other words, do 20 times pi in your calculator, and then that will give you the answer that WebAssign wants. It will be close to this for the approximation, but just make sure you're careful with that. If you do 20 times 3.14, sometimes it does not accept that answer. So to be safe, just do 20 times pi in your calculator, and then whatever value that is, they're going to tell you, you know, to approximate it to 1 decimal or 2 decimals or whatever the case may be. But yeah, so that's how you do that, just to be on the safe side. Just put pi in there into your calculator. It will want the exact, that's 20 times pi. But then when you go to the approximation, do 20 times pi in your calculator, not 20 times 3.14, but 20 times pi in your calculator, and let that do and approximate from that answer. And I'll do the same thing here for this other one when we get there. All right. So to find the area, we'll do the same thing. Plug 10 in for R. So that's pi times 10 squared. And that will be 100. And so that will be your exact answer there, 100 pi. And then substitute at 3.14 or just calculate with the 100 times pi in your calculator, and you'll get a number around 314. Noticing your, and I didn't mean to put that square right there. Notice that your area is inches squared. Your perimeter, not your perimeter, your circumference is just in your regular measurement of inches. All right. Question. Oh, it's okay. Yeah, it's no problem. Not a problem at all. Questions on what we did here? Make sure we're okay before we go to the next thing. So when it comes to perimeter or area, just remember that the shape matters, and you're going to use specific shapes, specific formulas for the specific shapes. All right, thank you. And that's it. That's what it is from there. So when you're trying these formulas out, if you get stuck on how to use them, feel free to bring those to class and we can talk about it. But it's just really about matching the formulas to the shape that you need to find the circumference or perimeter or area for, and you'll be good to go. Same thing goes with volume. Volume, remember I said the area and the volume, you need a formula in order to calculate them. So here, find the volume. The radius of the base of the cone is 8 centimeters. The height of the cone is 12 centimeters. All right. Oh, not a problem at all. Not a problem at all. Appreciate you guys letting me know. All right. So I did a little diagram there. It says that the radius of the base of the cone is 8 centimeters and the height of the cone is 12 centimeters. So like I said, this is my diagram right here. This right here is the formula for the volume of a cone. So you know you need a radius and the height, and that's what they gave us. And then you plug in accordingly. 1/3 is a part of the formula. So that's not, coming out of anywhere other than the formula. So you don't have to look for that. It's 1/3 times pi times 8 squared times 12. If I was doing it by hand, I would take that 1/3 into 12. Once again, if you have a calculator, it doesn't matter. You can just put all of this in the calculator and get your answer. And then, so 64 times 4 is 256. If they want the exact, this would be your exact answer. I think for the most part, you know what, never mind, I'll take it back. But yeah, if they want exact, that would be your exact answer. If not, approximation, 256 times pi, throw that in the calculator, and you should get 804.25. One in black. Next one, they give us a cylinder. So they give us 4 as the height, and notice they give us the diameter at the bottom as 6 meters. But in the formula for the cylinder, I need pi r squared h. So I need to go ahead and divide that diameter of 6 by 2 to get my radius. And that's 3.
Can you scroll back up real quick?
Right here.
Right there.
Yep, y'all. Make sure you, yep. If you ever need me to scroll up, always feel free to do so.
Thank you.
Not a problem. So plug in 3 for R and 4 for H. 3 squared is 9. So that's 9 times 4, which is 36. And then that'd be 36 pi. And 36 times pi, 113.097. And it just depends on, what decimal places they want you to round to. And make sure you pay attention to that because they will mark it wrong. If they ask for the 100th place and you give the 10th place or whatever the case may be, make sure you pay attention to the rounding place.
What did you just say?
Make sure you pay attention to the directions and where to round to, because if you round to the wrong place value, they will mark it wrong. If they mention the 100th place and you go to the 10th place, then they would mark it wrong. All right. That's it. Let me see if I got another. Oh, that is triangles. We need another one, right? See what we got going on here. Where's my book? Any questions while I get this book out?
So how does like the homework work? Do we just do like what you're teaching us in WebAssign every day?
Well, you want to do your best to keep up with the lectures. So this is 7.5. So we've done 7.1, 7.2, 7.3, and 7.5. So you want to get into those homeworks and knock them out as soon as possible. We haven't put a due date on them yet, but you don't want to, wait till the due date in order to do your homework.
Alrighty, thank you.
Yep, not a problem.
You want me
Can you
to-
scroll up?
All right, there.
Thank you.
Uh-huh. Surface area. Trying to find the surface area one. I thought I had one up there.
You want me to ask that homework question now?
Yeah, well, let me do one with the surface area. I should have had a surface area problem with it, and I don't see it. So I'm about to do it now, and then we'll knock out that problem.
Okay.
Yeah, I just want to do one with the surface area. All right, now somebody asked me to scroll up. Let me know when you finish.
I'm done.
All right, thank you very much. Oh, yeah. Height is. All right, so we have the diameter of the base of a cone is 5 meters, and the slant height is 4 meters. Find the surface area of the cone. All right, so writing down our givens. All right, so they gave us the diameter and they gave us the slant height, which is L in our formula. That's 4. All right, notice in the formula for the surface area, we have pi r squared plus pi r L. That means we need to go ahead and take our diameter divided by 2 in order to establish what our radius is. And once we've done that, we just plug it in. So pi times 2.5 squared plus pi times 2.5 times 4. So 2.5 squared is 6.25. 2.5 times 4 is 10. I can actually write that way. Add them together. And if they need the exact answer, that would be that. And then multiplying them together for the approximation. And we are in meters, so it'd be meters squared. All right. So like I said, I just want to do one that has surface area or ask about surface area, but it's still the same thought process. It's just using the formulas. Those formulas all over in the book. And if you don't feel like looking at the book, always can go to Google, Siri, Alexa. All the formulas are still the same. Those formulas don't change. So you would just ask, what's the formula for the surface area of a cone, and we'll give you the same thing. All right, before I get to your classmates' questions, any questions on what I've said up to this point? All right, let's see what we got going on. The textbook is called Mathematical Excursions. You guys get a copy of it, though. It should be a copy of it through WebAssign. Should have access to it. Should be able to click on.
It's free, correct?
Yep, it's free in WebAssign. Now, as far as a hard copy, though, I don't believe the school provides that, but you have free access to it through WebAssign. So I think the main thing for you guys is for those who don't have access to get that access. And that's what we're going to be working on with the rep and see what's going on with some of you guys' account. Yep. But yep, like she said, it is free. All right. So your question, ma'am, I didn't see who was asking that question, so I got my video minimized. All right. All right. Yeah, who had that question earlier? The first question? And I said we would get back to it.
It was me.
Is that Miss Clay?
Yes.
Okay, great. I was trying to figure out because I got a whole bunch of people up. Yeah.
Do you want me to just tell you what it was? Or
That's fine.
so it said find the weight in pounds of an 85-kilogram person. And the answer is
All right. So you're talking low. You said find the weight.
yes. Find the weight in pounds
Okay.
of an 85-kilogram person.
Okay. All right. So I need the conversion factor, kilograms of pounds. All right. So let me do this. All right. So there's 1 kilogram, 2.2 pounds. All right, so there's 1 kilogram. For 1 kilogram, they're 2.2 pounds. So we'll set up our kilograms, 85 kilograms, and place it over 1. And because I have kilograms here, then that means I need kilograms down here. So that'd be 2.2 pounds over the 1 kilogram. So the kilograms will cancel. And then we just multiply across. And so 85 times 2.2. It's going to be 1.
187.
Yep, thank you. And that's 187 pounds. So you go off what you were left in. All right.
Thank you.
Yep, not a problem. All right, so did you have another one or was that good?
Got one more.
Okay.
Okay. The last one it said you have 6 kilograms, and a ham costs $16 kilograms, and it says find the cost per pound.
Okay. So you have let me make sure I got this right. You have a $16 ham
It says
that's
ham-
6 kilograms.
It says yeah, the ham 6 kilograms, and it costs 16.
All right, yeah, I could have wrote that better then. So you got a 6 kilogram ham that costs $16. Okay. So first thing I would do is convert the 6 kilograms to pounds. Turn that red. Once again, kilogram over kilogram.
13.2.
Oh, somebody on top of that thing. Appreciate it. 13.2 pounds. So now if you want to know cost per pound, talk about dollars over pound.
Yes.
That divisional bar represents per, if you're talking about word-wise. So I would take the $16 and place it over 13.2 pounds and then divide that. So it's 16 divided by 13.2. That would be, since we're in cents, $1.21 $1.21 per pound. Yeah. So that should be it.
So we'll write the per pound in with the
Checking WebAssign. I don't know how they got this set up because they may just have a box and then have per pound on the outside, or yeah. So see how they want you to write that in there, but yeah, but that's what it would mean.
Okay. Thank you.
Not a problem. All right. Anybody else have any other questions before we close out today? Everybody good? All right. So make sure you guys try this stuff out. See if you have any questions. We have one more section in chapter 7, and that's 7.4. What's the name of this topic? Just converting measurement. That was out of 7.1. If you're talking about what she just asked about, somebody typed in chat, what's the name of this topic? Just converting measurements out of 7.1. All right. Anything else? Anybody else? Pretty good. All right. You guys have a great weekend. Oh, got somebody else in the chat, but numbers on Blackboard. Yeah. Y'all have a great weekend. Y'all be safe. If you have any questions, feel free to email me. Don't forget the Super Bowl question if you want that extra credit. If not, it's all good. Somebody
You
say
have a
something?
great day too.
Thanks. I appreciate it. I
No
appreciate it.
problem.
All right. Y'all have a good one and take care. I think people dropping numbers in there, so I'll let y'all finish that out before I close out the meeting. So y'all have a good one.